I think we just had someone arrive, but we'll get started anyway. Great, so this is our page we are working from for this course for rockefelleruniversity.github.io. Anyone wanting to follow along at their own pace, you can just work through the material yourself as well. We should have the videos up for the current session. If I click here, we've got the intro to R, and that includes the reproducible R part we have, and I haven't added the nice front page for the video yet, but I will. So I'm trying to keep that out there every evening when we finish. I will upload that video. We've turned off the waiting room in the Zoom, so you should just be able to walk in. There shouldn't be worries about the waiting room. I know that's an issue, I'm sorry. We have started in our course. We've been through our intro to R. It's really just taught us the major data types: vector, matrix, data frame, list, factor. We saw a little bit about looping, a little bit about conditionals, everything we would need to know to handle our data later on. Not so much functions. We didn't go into too much detail, but we covered them a little bit. And then we skipped forward to reproducible R. And I just showed you a little bit on R Markdown. And R Markdown is this wonderful framework which combines R with Markdown, allows you to make these reproducible. So now we're going to come into our plotting in R sessions. Now, plotting in R is a lot of what people come to R for. R is famous for its plotting capabilities. So it's a good little, good to cover this at the beginning. Today, being 4th of July, we're only going to have one, not 4th of July today, obviously, but we're going to have one session today, just this first session. It is a longer session, though, and then we'll have the exercises. The second session we won't run today because the second session is one of the most important sessions we have in this course. It is ggplot, and it is how a lot of you will make graphs, and I want to do that in one day. So that's 2 sessions, and I want to do that all together. So we'll take an early day today, we'll take a break, and then next week I'm going to make a couple of updates for ggplot course as well. I want to add some interactive graphics because they're really cool, and they keep expanding the repertoire we could use. But we'll get started with this plotting in our first session. Recording, sharing. Great. As usual, just back on the page, everything you need to set it up is here, the installation, what packages you need. You can download all the material from here, and that includes all the slides, all the exercises, everything, so you can have that on your computer. We never take down these pages, they're always up, but if you want to take a copy, take that. And then we're working through these slides. If you haven't been here before, remembering these are great, these slides, but if you want to come back, you know that we did something in a particular session, go to the single page, because single page you can do Control F, you can search for that bit you were looking for, right? Slides you can't search. That was one of the comments the first year I did this course. So let's get started with introduction to plotting. What's the time? Good, great. I'm gonna try and hide some of this stuff. So we can get all the prerequisites. Once you've downloaded everything, we should know by now where the slides are. And if you want to set your working directory, we know to set it to the R course directory in our downloads, if we want to follow along. So, I mean, you can't understate this. R has really excellent graphics and plotting capabilities. And if you're coming from languages like Java or C, you're going to be impressed by what you can do in R. Python does have quite an extensive set of plotting capabilities too, as with MATLAB and as with things like SAS and Prism. But I really think that R is leading here. And they're really found in 3 following sources. We have what is base graphics. And just to remind you, base, I'll show you in R later maybe, but base is what is attached when you load R. R. So this is no packages installed. All this functionality comes when you download R. Beyond that, and probably now it's a bit dated, but there really are two major alternatives to plotting. One is called lattice, which we're not going to teach, but in your own experience, you may come across. Lattice is good for really high multifactorial data. And then we'll come across ggplot2, and we will teach that. That will be our session next time. Probably the most popular plotting package in the world, any language. So the big difference between these two other packages, base graphics, is that base graphics is going to use what is called a pen and paper model. So not a pencil and paper model, a pen and paper model. While lattice and ggplot2, and we'll go into more detail on them in the sessions, they're built on routines first, used in what is termed grid graphics. And that's not just an R thing, that's a much bigger way of doing graphics. Okay, but we're going to concentrate on base R, which does this pen and paper model. And what is a pen and paper model? Well, it's very simple. It's just like as if you're writing, you have a blank piece of paper and you put a mark on it with a pen. Once you've made that mark, to change it, really, you're going to have to get a new piece of paper. So we can keep on adding to our plot, but we can't really take anything away from it. So this is actually makes it very fast. Once we've written to the paper, we don't need to think about what's on the paper anymore so much. We just carry on writing on top of it. But it does mean that it's very hard to update. If I gave you a plot, you can't then take apart the elements within it. And if you think a little bit, I'm not sure if you've done much graphics and things like Illustrator, but if you're using these programs, you know you can take apart the elements of your plot, the axis, the points. Can't really do that with this base graphics. So building a new plot in base graphics is very stepwise. I'll make my borders. I will then put a line on it. Then I will add a legend. Okay. Often you will just need to plot. Okay, my plot wasn't quite right. I will just do a new plot and I will change these features. So all that pen and paper model as opposed to what we will show you next time, which is more of a blueprint. What would I like to put on the paper? Here, we're writing to the paper kind of in a stepwise fashion. So the first thing we're going to look at is scatter and line graph. So to do this, we're just going to need a very simple numeric vector. So I'm going to produce a vector here, treatment, and I'm going to use our combine function, and I'll just combine a few numbers, 0.01, 0.02, 1.8, 17, 55, 75, 80. Just some numbers in ascending order. Do any type of plotting right out of the box. We can just use plot. Okay, so we can even have a look at the plot function. We'll do that in a few slides. If you just look at its help and describe a bit more for us. But plot, in its very basic form, will just take a vector, and it's going to produce the plot for us. And it adds, so here it's produced a scatter plot. You can see on the Y, we have the values for our treatment, right? And it's actually taken the name of our variable here, and it's placed that in the Y-axis label. It's pretty clever of it. And then it's got our values along here. Along the X-axis, we have the index. So this is the position in the vector. So for the first position in the vector, it was 0.02, then 18, and that. And it's actually given us the name index too. So it's done a lot of the actual work for us just by doing plot. It's given us a label, given us the index here, and then it's just given us a standard kind of point plot. So that's at the most basic. So we can actually have a variety of different plot types just by controlling it with this type argument. So here we have plot, treatment. If we want to have what is called an overlaid line, we can go type equals here in quotes O. And you can see it's going to do circles, line, circle, line, circle, circle. We can also do things like just a line, which is useful. Here, just type equals L. That's going to be a line between our points, and we can do type equals P, and it'll just do points. As I say here, we can have a look at question mark plot. If I do that in R, we can have a little look at the options available to us. I've already done it. Question mark. It's actually kind of interesting. I think if you do double question mark, it does like a free text search of the R help. In this case, we just want to do plot. We can see in the base library generic XY plotting. And then we have all the types which we could plot in the help, nicely explained here. So we've got P for points, L for lines, B for both. I'm not really sure what the difference between both and overplotting is. And then all the various other functions here, including N, which actually just gives you a totally empty plot. That can be useful when you just want the ranges, the boxes to be right, but nothing actually within the plot itself. Okay. You can also very easily add some type of title to this. So we can do here, I can just add an option main. And we can do main equals my plot. And it's going to add this above my plot. And if I do sub a plot, we're just going to put that underneath. So this is our caption. And then this would be our main kind of title for our figure. We can also control both the X and Y labels as well. Going to pop up at the back. So we can set our X label and our Y label. Thank you. So Y label we put here, we just put score. And X lab we put position, and it just removes in this case, or we haven't actually plotted it, but we don't no longer get the generic label here, treatment and index. Instead, it's put our position and score. You can also, and this is really useful, control the orientation of the labels on the axis. So we have this argument las. I'm never quite sure how best to describe this, but I think we can set it as 0, 1, or 2. And it's going to change the orientation. So 1 here, everything's this way. If we do 2, these are kind of going this way. And I think we can do 0 as well. But if we get confused, we can just look at our help. Oh. 0 always parallel to the axis, 1 always horizontal. 0 is probably the most useful when parallel to the axis. Always horizontal, always perpendicular to the axis, 3 always vertical. So we can always get the help to kind of explain to us what our options are here. We can also, another really useful one is this CEX, character expansion parameter. So whatever you're putting inside your plot is a character. We can expand, so like points. If we start putting text in there, those are all characters. If we want to make them bigger or smaller, we just set the character expansion factor, and we set it to be 2, they will be twice as big. If we set it to be 0.5, they're going to be 50% the size. We can also control the type of plots we want. If we wanted to, we can do here PCH equals 1. I think this is the generic empty kind of point. Or we can set them to be anywhere between, I think there's a whole variety of different points I'll show you now. Here we can set 20, which is often what we want, and it's just a solid dot all in our plot. I think I'm going to come through these options and we'll go back to the plot, and I'm going to show you where you can look up all these parameters, because the most important thing is being able to find these parameters yourself. So I'm going to just carry on for now. Similarly, whereas this controlled character expansion, so points, text we put in our plot. If we want to control the size of the line, we need to do the LWD. So this is the line width parameter. I'm not sure what the D stands for. Line width. So I said that to be 10, it's going to be 10 times bigger. 0.5, it will be 50%. We can also do similar to PCH. We can do LTY, which is going to give us different types of lines. So you might want to have a different line for different types of data. But here, if we do 1, it's our standard line. If we do 2, it's going to be a dashed line. Similarly, there's going to be like dot dash, wider dash, all this stuff. I can show you all those options myself. Another really useful one is color. So in this case, I don't think we distinguish between color and fill. So a lot of graphical parameters differentiate between color and fill. Fill being inside a point, color being the outside. In this case, col corresponds to just the color of whatever we're plotting. So here we do red, and here we got color, and we do Dodger. My old boss liked the Dodgers, so we get a lot of Dodger blue. If you ever use DSeek2, which we will use, I think, in some of the ChipSeek, he uses Dodger blue for all his plots. There is a really good color chart, and this will talk you through all the available colors in base R. Okay, and we're going to show you, again, ggplot's the one I slightly prefer. We'll do that after the 4th of July. But you can make up your own color schemes. You can make up your own colors. These are just what's available by base. You can see they go on for a while, and they seem to be biased towards the grays. Oh, it's British spelling of gray as well. You can see you have lots of options available to you there. So if you really want to know, like dig down into what actually these plot functions can do and the options, you're going to have a look at plot. If I do that here, you can pull up a little bit of information about plot. You can see I have 2 helps here. Okay, if you ever see 2 helps, it's often best just looking at the base one first, and this is from the package base. And the reason we're going to see lots of helps here is actually kind of described here. For simple scatter plots, which is what we've been using, plot default, this is going to be what we use. For more complex R objects, so when we start to do RNA-seq, ChIP-seq, single cell, you'll find that the objects, these R objects which contain that information, have their own plot functions. So by doing plot and passing it that object is going to do something totally different to if I give it a vector. Okay. We'll discover that in time, but right now we're just using base plot, so that's all we've learned. Right? So if we look through the arguments, plot, it takes either an X or a Y, and then an additional set of arguments here. We're only giving it one value, a vector. Right? So those are the coordinates of the points in the plot. Single plotting structure, we're not giving it that. Y, the Y coordinates of the plot, optional if X is an appropriate structure. So actually Y isn't required. We can just give it X, and as we saw, it plots the values in X versus their index. And then we can see we have all these options like type, we went through, but there aren't as many options as I've shown you. So if we really want to dig down into all the options in plotting, we actually have to go into par, which is parameter. And inside here, we have all those options we discussed, all these things we control. So PCH, I think, is here somewhere. Here we go. PCH, yeah. So you can see in PCH, there's the different points. It's actually going to link me to another help. And if I go there, it actually draws out the different types of points. So plotting, we have this one function, but we have a lot of options. If you really want to dig down into all the options, the different points, the different lines, really just doing question mark plot, and then following those options down will bring you into this. And you can see we have, like just for PCH, we have a ton of different available plot types, but really 20 was kind of what I'm interested in. It's just a small standard kind of one. Okay. plot function, as we just saw, though, can actually take two. And I think the most useful part of the plot function is doing scatter plots. You have two columns, and you just want to know how they relate to each other. The best thing you can do is plot them side by side. They go in a straight line along an X and Y. They're highly correlated. They go opposite in an X and Y, they're not. So, you know, plot one vector versus another vector is super easy. And we can just do that here. And it gives us, again, sensible labels for the X and the Y. So I actually know the orientation treatment got put here and control. Again, the reason this is really nice is plot is also very fast. When I show you ggplot, it's going to be a little slower. When you have two very large vectors and you just want to see how they correlate, plot will work well. We often want to put multiple lines on the same plot. So actually what would happen if we wanted to plot not them versus each other, but in terms of their indexes? So we can use another function for this called lines. And what lines is going to do is add to the current plot a new line, right? So if I just did plot and tried to do it again, the old plot would disappear and a new plot would appear. Right? This is going to add the lines for this to the current plot. So I'll start by doing the treatment. I'll plot that. Then I can do lines, and I'll give it the same setup here. I'm going to give it control vector. I'm going to tell it again an overplot. I'm going to give it a new PCH, so a new type of character to plot. It's going to be a square. A new type of line, it will be 2, so I can differentiate. And then color, I'm going to call it red, so I can just see the 2. So hopefully we can already see there's a slight problem here. The red is going off the range of the plot. Right? And then it's just being cut off. And this is more of this kind of pen and paper model. When I made the first plot, it was with treatment, and that defined automatically the range of my box. Okay, so treatment line didn't have quite such a high value as we saw in control, therefore the control was actually going off the side of the plot. So we can control that, but we would need to know kind of upfront what are the limits of our plot, what we actually want to include as the maximum and the minimum. So here again, I've got my control, but this time I'm actually going to set some limits for my plot so I can explicitly control the range of both my X and my Y axis by using this XLim or YLim arguments. So in this case, I knew that my YLim was wrong because this is clearly going off the side of the plot. I know here I'm looking at my vector because I'm creating it. I know that the top limit is 100. So now I just do YLim, C 0, 100. So I tell it YLim, I give it a vector with the minimum and the maximum of my range. And now when it makes that plot, you can see I go from 0 to 100. And when I put the lines on this, it's going to actually fit into the plot. So that looks a lot better. You can see it goes a little bit beyond 100, right? So when you set these limits, it's not exactly on 100. It wants to give me a bit of space. So we knew up front, because I just did that in the same bit of code, what the limit was. So maybe we can actually use a function to try and determine what are limits of our plot. So in this case, I'm going to use the function range. Okay, and I'm going to give it, range will take, actually, I'm not really sure how range works. So if we look in the help, I think range is just going to take vectors and give me the any numeric or character object. And it's going to return to me the minimum and the maximum. Okay. So in this case, I know that I want the minimum of my plot to be 0. So I'm going to give the value 0. And then I'm going to give it my treatment vector, my control vector, separated by commas. And then this function will return the minimum value in my vectors and the maximum. Okay, so I can get 0, 100 more programmatically than having to look at my actual vectors and find out the minimum. So now I've done that. You can also see that the range is a minimum maximum, which is perfect for the input to the ylim parameter. Oh, yes. Oh, yeah. No, exactly, yes. You're 100% right. So the reason I add 0 there is because I know I want the bottom of my plot to be 0. So, no, so let's have a go, actually. So, oh, actually, control's got 0 here, but it's a really good question. Let's have a look. So if I do range, say 10 to 20, it's going to give me the minimum and the maximum. But in that case, I was worried that, say, my minimum wasn't a 0. Maybe I had a minimum value in my vectors of 2 or 3. So I put 0 there to make sure that my minimum was going to be 0. So I was kind of fixing it a little bit. But yes, exactly. Range just returns the range of the data we're actually giving it. So if the minimum was greater than 0, it's going to return whatever that was. So yeah, here I deliberately put in 0. So I wanted that to be the minimum. Okay. So now with that, we can now do our plot. And I'm going to redo our plot treatment. But I'm now going to start to turn off some of the things which have been explicitly put there before. So we have our treatment. I'm going to say type O, overplot, color equals blue. I gave it my ylim, but now I'm going to set axis to be false and annotation to be false. And then it's going to turn off both my axes, so we don't have any axis anymore. But it's also going to turn off my Y labels, my X labels, and my tick marks. So we end up with a very minimalistic kind of looking plot. This is me trying to show you that, the pen and paper model. So we'll now add them back in. We can then actually include back on the X-axis or the Y-axis. And in this case, we're going to add an axis for the bottom, the X. So we're going to say axis. I'm going to use this function. I'm going to tell it the side I want to operate on. And I can give it an option of 1, 2, 3, or 4. 1 being the bottom, 2 being here, 3 being here, 4 being on the right. To know that, I would do question mark axis and look up what it tells me. And I can guarantee it's going to say 1 minute. I then need to give it where I want to put my tick marks. So I want to put my tick marks at position 1, 2, 3, 4, 5, 6. Remembering my treatment vector is 6 long. So that's at these ticks, I want to put a new label. So I'm saying at 1 to 6, and at the positions across there, I want to put Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Okay, so now I can do an axis just by telling it the actual numeric positions along that axis to put the ticks at. I can now put in my own custom kind of tick labels across that axis. So similarly, I can do axis 2, and then it's going to put the axis on this side for me. I'm going to set, remember we set last, this is the kind of angling of the text. Okay, so here we're setting that to be 1. And then I'm going to set here at, and I'm going to create a range of values using the seek function from 0, which we know is the minimum, to the maximum in the range. And then I want to do it by every 20 to make it more regular. So we have our 2 axes now. You can see that they're not quite attached. It's because it's actually not the axis which attaches, it's something, the box element of the plot. So if I now run this box function, it's going to put a box around my plot, which will make it look a little bit more like a standard kind of base graphics plot. But without that, I actually think it looks a little prettier. We can just have the axis on the bottom and the top. This box just fills in the rest. So now we can add in the lines to this because we know the ranges were set correctly when I built it originally. I set it with the result of the range function. So I'm going to add my lines. Type equals O, point type is 22, line type is 2, and then I'll give it the colors. Finally, we're going to use a slightly strange function to me, this legend function. Okay. And a legend allows us to put, literally that, a legend within our plot. Annoyingly, a legend is going to force us to put this within our plot. So we need some space in our plot to actually put the legend. So to do this, all we need to say here is legend. And I tell it descriptive here, top left, left, bottom left, middle, bottom, right, and all this. Right? So I can give it a position here. I said top left. I can also give this an XY coordinate here. So if I gave it a vector of 2, it would try and put that center of the legend at that XY coordinate. I tell it what I want to put in my legend. So I'm going to say I want treatment and control. I tell it the colors, okay, but I have to remember this. I have to get this right. It's not automatically putting this together for me. Blue and red in the same order. And then I'm going to tell it the point type I used and then the line type I used. What's slightly annoying about this is there's no clever connection between the point and the legend. If I was to mess up the legend at this point and just get it backwards, the plot's ruined. This is what's great about ggplot we're going to come to. But still, we have quite a lot of control. Right? Maybe I'll just show us legend as well so we can have a little look at the options. So here you can see X, Y coordinates to be used. This can be specified by keyword, which is what we just did, top left, right left. Or we can actually give it an exact position. And I think if I look in details, it'll say here what's acceptable. Bottom right, bottom left, left, top right, right, center. Okay. So we've also, I'm sure we have any code for that. Oh yeah. So we might want to also just add one more thing to this and try and differentiate the thickness of these actual lines. So in that case, we just needed to change the LWD option here to be 2.5. And then I can add that additionally to this point. So anything we change in the plots, we also want to be able to update the legend. And the legend function will take the same arguments as the points as the plot function itself. So I showed you earlier on that we have this standard R color scheme, right? And these contain all the ranges of colors we can use. So we'll get a bit more into this again in our second sessions, but behind color schemes, there's lots of ways of saying color. RGB is one of them, red, green, and blue. Hexadecimal colors. The ways of encoding colors are all are complex, but we can actually make use of any of them inside of them. One thing I really advise you, I'm not sure if, is anyone colorblind here? Yeah, so this is an important slide for you. I cannot understate every time you do a talk, there is someone in the audience who's colorblind. And they totally miss the point of the plot. And I think unless you're really colorblind, you kind of miss this. Viridis is a really great package because what it provides to us is a set of color schemes, like the colors we can use together, which are always differentiatable by, is that the word, differentiated? By people who are color. So the real problem is that most genomics, we like red-green heat maps, and those are awful. Colorblind people. You can do things like blue-yellow, and we're often a lot better off using that. So palettes exist for curated colors. These can be themed around anything from Le Croix colors to Pokemon. I'm not sure if anyone's a fan of films like The Royal Tenenbaums or something. You'll get the palettes and the color schemes from your favorite movies are available online often. I think they've just done a Marvel one as well. So you can find a list of color palettes here. Palette here. There's lots of available color palettes. go through, not a complete list. And again, I'm going to show you in the next session how you can create your own kind of color palettes. For now, we can take advantage of this Viridis package. Here's a whole manual on how to use it. But if we want to get any package and install anything which contains additional functionality, we know we can just use install.packages, give it the name of the package we want. It will go and retrieve this package. I can load the package. And then if I want a color scheme of 5 colors, which are distinct enough that colorblind people can tell the difference, I just use the standard Viridis function and provide the number of colors I want. So in this case, I asked for 5 and it gave me these 5 colors that were distinct. Can you tell the difference between those 5 colors? That's a test there. Great. We don't go into this much, but this isn't to underestimate this. So when I used to do this talk in Cambridge, I used to do it with a guy who was very into visualization. And he had a really good example which demonstrated this. But this book is fantastic if you want to learn a little bit more about visualization. I'll tell you, this book uses ggplot, which we're going to teach you next. But we need to teach you base graphics because lots of people do use it. Fundamentally, is it digestible, accessible, engaging and appealing? These are all up to you in many ways about your plot. This part is often the bit which people, for whatever reason, like to put superfluous information in their plots. Flowery outsides, additional kind of styling. I would always say keep your plots as simple as possible. I think Leslie's Ravossel's running this one plot thing on Twitter at the moment. Right? A lot of those plots are very simple. Keep the plot simple, just get across the message you want. Really, this book here is in-depth, built with Markdown, so you can build these books yourself in our Markdown. But it covers not just how to do it, but fundamental understandings of what you would want to put in the plot. You don't want too much white space in your plot, stuff like this. So base graphics, things like plot. This is our default function. Really, we're going to use this mostly for doing scatter plots and line plots. As we get into other packages, they will contain their own plot function. And we can just use plot on their object and it will generate a plot customized to them. I said I'm going to teach us ggplot, and ggplot has some really great graphics. And I really want you to concentrate on using that for your plotting for many reasons. But like I said, base graphics is fast. And a lot of the times you just need to see your data. Base graphics is going to get you there on your laptop much quicker than a ggplot. And then you can make the nice ggplot which you want to submit with your paper. Right? So I'm going to run through some plots which are available in base graphics, and the last one there being Boxplots. And these are all separate functions, which also makes them slightly painful compared to ggplot or just the plot function. But I'm going to talk you through them, and I think these are just the useful ones available. Okay. So one plot which a lot of statisticians hate is bar charts. I hate it because there's all this space. But they are very useful still, I find, to actually look at your data. We can do a bar plot really easily just by giving it our vector. So we still use the same vector. I give it the bar plot. I give it to the bar plot function. You can see it doesn't put anything along the x-axis, but along the y, we have our depth or number. You can see it just places it like that. If we want to, we can quickly add names directly to our plot just by using this names.arg function parameter. And we have to give it the same number of names as we do here. Otherwise, it will try and recycle names. So if I only gave it Monday and Tuesday, it would go Monday, Tuesday, Monday, Tuesday, Monday, Tuesday. But here, we don't need to change anything in the actual vector. We can just provide the names here. And it'll give us this kind of simple but elegant bar plot. If we want to, we can just name our vector. So here I can do names, assign the names of the days to our vector. So it's no longer just indexes. We have names associated. Now I just give that one vector, one parameter bar plot, and it takes the names in my vector and uses them for my y-axis plot. A really useful thing about bar plots here in R is this ability to do stacking. So we can kind of put bars on top of each other or side by side next to each other. So to do that, we actually need to read in some data, which we have available, hopefully, in our data directory in the R course, and downloaded it. So we'll just assume we do. So to read in data, we saw this before, we can do read.table. Yes, just have to tell it I want to include the header. I tell it my row names are in the first column. I tell it my separator is comma, and then I'll get my data frame back from this function. The bar plot takes a matrix. So even though I've read in a data frame, I need to change it to a matrix. The only difference between data frames and matrices being really, I mean, there are other things, but really a data frame can have mixed data types. Data frame can have a column of numeric, column of factor, a column of characters. A matrix has to be all character, all numeric. So that's really important for when we want to pass it to plotting features. Up front, that plot knows it can be short. It's all going to be numbers. I don't need to worry about it. So I'm actually going to download this so I can. It'll take me a sec, sorry. I just want to have a look at this matrix. Oh, that was fast internet speeds here. So I'm going to try and read that in. So I'm going to say session, set working directory, choose directory. I'm going to go to my downloads. Plotting in R. I'm going to set the R course to be my working directory. And I should just be able to follow the lines we had in those slides there. It's easy to copy out of it. Okay, so then we have a data frame where we have a column treatment, column control, and then we have row names, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. I think that is a data frame. Yep. So we can turn this into a matrix. Just put in has got matrix. Has got matrix. So it looks absolutely the same to us, but under the hood now, this has been converted, and R is assured that it's all. So if we pass that matrix to the bar plot, there's something kind of interesting as it tries to stack all the values in that matrix on top of each other for the treatment column and for the control column. So what it's done is stacked the value 0.02, 1.8, all on top of each other. And then the control column has done the same. Slightly more in our control, so it's a higher end. You can also plot this data the slightly tidier way using this beside argument. This is often how people want to do this. Really, you kind of want bar charts across the columns. So just by saying beside equals true, what it does is it splits our columns now into kind of facets across the Y. And we'll have treatment here, so it gives us a name for based on the column, and it gives us a name based on the column here, and then it's put in the values. I provided some color scale, some type of grayscale. One slight, I mean, you're going to like ggplot for so many reasons, but one of the reasons is it has uniform arguments. Right? So I showed you the plot function. Now we're using the bar plot function. A lot of the arguments are going to be the same. Nice, but there will be subtly different. In this case, we can take advantage of some of the customization. We can give it a main. So this, we can do the Y lab. Say total. Yeah, so it's going to give me my Y label. I'm saying beside equals true, so I already have the labels here and I split them. I'm going to take advantage of the fact that we installed the Viridis package. So I want, rather than grayscale, I want to have 6 colors selected from the Viridis package. So to do that, I just use the function Viridis, and I give it the number 6. And that's just going to give me 6 distinct colors. Not that distinct, but, you know. And then I'll add the legend. I say top left. We don't have much space here, so top left is pretty much left. And then I give it the same vector I want: Monday, Tuesday, Wednesday, Thursday, Friday. Tell it the character expansion. So I'm making this bit smaller. This is already a problem with plot. I have to find space for my legend in my graph. And then I'll give it the Viridis colors, so I can then know which color corresponds. Already I can get an idea over the days, no difference between control and treatment. How much time have I got? Another function which out of the box is super useful inside R is hist. Because hist is actually going to do a little bit of stats for you. It's going to try and group your data into blocks and basically represent the distribution of your data as a histogram. So given treatment, I can ask it to make me a histogram of it just by going hist, giving it the treatment vector, and it gives me kind of the frequency within those blocks of treatment. I have 2, maybe, or 3 within this range, 1 within this range, and then 2 within this range. So telling me how many of my vector are within these different ranges. Okay, just like with plot, we can customize some of this the same way. So if I want to, I can add color equals light blue. I can set ylim here, and I can set things like size of the character expansion for my name. Here. By default, I haven't given it a title. It's just, you know, taken the name of the vector and said histogram of that. So it's done something clever there. Probably the thing you really want to change in a histogram is how many breaks you have, the resolution of this. Okay, so already, if you don't have many values, it's not going to make much of a difference. But changing the breaks is a good idea. So we can actually define how many bins we really need from our data by specifying the breaks argument. And here I'm just going to specify 2. I'll get 2, and it really doesn't represent the distribution at all. Here I would say I need 10 breaks, and I will get 10 breaks across here. And perhaps that does show a slightly better distribution. But the really important additional argument there is breaks. Don't need to do anything more. It can group our data and give us, if you want to know your data is normally distributed, you'll pass it. So I think the 2 last plots we want to show are Boxplots and dot plots. So dot charts. So dot charts are, I think, very useful when you have paired data. So you have 2 values side by side, and I want to show on one plot. So first off, we need to do one trick we haven't done yet to a matrix, which is transpose it. So if our matrix is going control treatment, and we want column names control and treatment, but we want them to be rows control and treatment, and transpose it. So where do I get this data from? Let me show you that anyway. Oh, here's data. So this is as matrix. I do T. You can just see it just turns it the other orientation. Right, so treatment now in the rows, control them there, but it maintains the column and row labels. It just switch them over. So dot chart wants me to do that T first. It wants the data in a slightly different way. Because if I do it like that, it's going to group the data by the columns. But if I do it with a T, I put it into pies. So it really doesn't fit well on my slide. I'm sorry. It looks better in the actual graph. Anyway, so we can actually see it here. What it does then is this is our what we're plotting when it's transposed. For every column, it kind of creates a sub row and then it puts the two rows next to each other. So we can kind of have nested plots. And if you can get the coloring scheme right on this, you can really make some easy to follow plots. And you can see here the big difference is on Tuesday, but Monday was very close. And then say Thursday, they were very similar. Friday, they were very similar. Maybe. As with other plots, we can add color to this. The color is going to be recycled. So in this case, if I want to go red and blue, I'll just give it two values. I don't need to go for every single dot. And it's going to then cycle through red, blue, red, blue, red, blue, red, blue, red, blue, red, blue. I can give it a main, so I can give it, like with a lot of the plot functions, I can give it a main title. And finally, I can give it the character expansion, and that will control both these, but also these points. Whereas there, it was kind of messy, it's overlapping. By changing the character expansion, they get smaller, they don't overlap, they're a lot more. Okay, so the final plot I want to talk about today is Boxplots. So Boxplots are actually fantastic, maybe better than GTPlots. They're just so easy to do, and they're so informative because they give you a wonderful, you can see here, they tell you the medium, the quartiles, and the extremes of your data, the minimum and the maximum. So in this one thing, you can summarize a lot of information about a column of data. And often if I put boxes next to each other, I could say this column has a different distribution to this column, has a different maximum, minimum, range, quartiles, different distribution. So these are really useful plots. And they take a long time to do inside some other graphical things, but in R, they can be slow. They're a lot faster. So the first thing we need to do is read in some here gene expression data. Because this is often what we use Boxplots for. We want to know the distribution of signal. It's the same across our gene expression data. So here we're going to read in some real data. I got some gene expression data in the data directory. It's tab separated, so we separate by tab. There are column headers, so header equals true. And I want to put the row names into the, I want to take the row names from the first column and put it straight into the row names there. Remembering from our reading and writing thing, the reason we really like to set the row names as we read in means that we can turn this straight into a matrix, and it won't be a mixed data type matrix. We're never going to have row names in it. They're character, the rest of it's numeric. So once we've got this, we can pass this straight to Boxplot. It doesn't matter, it's a data frame. It's going to translate it to a matrix internally. And it will give us our distribution of values. We can't actually see much here because most of the data is so close to zero. What we can do, though, is just quickly apply one new function, log2, and that's going to do a log2 transformation to every value in our matrix. And now, if we do the plot, we can see that actually our data is pretty similarly distributed. Our means look roughly the same. Our medians, based on this line, look roughly the same. Distributions are a little different, maybe. Maybe this one sticks out a little bit. Slightly odd about that one. Then I might want to go investigate. But we can just give a matrix or a data frame here. As long as it's all numeric values, we can just pass that to Boxplot. The columns will be separate boxes here, and the columns contain the distribution of values for all the rows. So we can just set color. We can also just set colors here. So color, and just set red, red, blue, blue. Okay, so I think those are the major plots I want to show you. I'm just going to show you a little bit about combining plots and then writing them out. So R makes it easy to combine multiple plots into one overall graph. It's not easier than just taking it out and copying and pasting it in PowerPoint or Illustrator, but we can do this inside R directly. by using some options inside par for this layout. So with the par function, we just need to provide some new options here. We just either need to set a number of rows, MF rows or MF cols, which will then tell it to, in this case, fill out a 2x2 matrix of plots. So let's just see this in action. So this is going to cause you a lot of fun, I'm sure, at points as well. So if I do this, nothing changes. But now if I do my dot chart, it's going to start with the top left. So if I did MF col, I think it's going to work by columns. Fill up the top. I did MF row, 2x2. If I do another dot chart, we'll put it there. If I go back to, did I do any other plots? Let's do a plot. So you can just fill out your plotting window with your plots in that one. The slightly annoying thing now is that if you don't turn this off, if you don't reset this to 1-1, next time you do a plot, it's going to be in your top left. So you then need to actually reset this once you've done with it. Now if you do a plot, it can take back the plotting. Yeah, and we're going to have different ways of doing that in our next section. You can see here, we can just do par MF row 2x2, and then it's histogram of this, comes here, then here, then here, then here. If I did MF col 2x2, it would go here and work by columns. There, there. You also do this in a loop. Yes, this is actually quite cool. You might do MF row 2x2, maybe even work it out from the length of your list containing your results, number of columns, and then here, just loop through the first 4 columns, making it. Par you can also actually control, and par, this par function goes deep inside R, and because we're going to cover mostly ggplot, not going to do too much. But one thing you might want to look at is mar, is the size of the margins around your plot. So sometimes you want to make them bigger, smaller, to fit in your big labels in your XLabs. Fig, we won't use too much, but you can also control, say, spacing between the elements of your plot. We look again at par, let's just remind ourselves. It's done. MA, MAR, MEX. That gives you a good description of all of these things, how you can use them. So we'll say MAI, we're going to give it a vector of 4, which controls, how much of a size you have around the margin. So this is the actual plot window where your X labs and your Y labs and your main go. Okay, shapes not so much, but one thing you really do want to be able to add to your plot is text. So given that you have a point you're particularly interested in, you might want to put some text within your scatter plot to say, this is the name of this gene. So we can do that really easily inside R by just doing our plot. And then if we want to do text, we can just say text, and we can give it the X and the Y position of where we want to put it inside our plot. We give it the actual text we want to have, and then we can give it, say here, in this case, color, but we could also give character expansion values. So in this case, I've said put it at 2060, and you can see the text is centered around 2060. So centered on 2060. 2060. Yeah. So that's going to be ggplot more easily. I'm sure you can do it here. So what you would probably do is, so if I'm plotting, say, control and treatment, I kind of know where the positions are. So I could probably extract from control and treatment where to put this if I wanted it by a point. But ggplot's going to do this for us. So it's not even worth worrying about. Another really useful thing is add lines. So if you have an X and Y, and this is your cutoff, I need to be above a one-fold change, adding a line to your plot is useful. So we can use add lines like here, to add vertical, horizontal, or actual slope lines to our plot. So in this case, what some of the most useful is add line. We'll say we want it at horizontal 10. Okay, so there it is. I'm going to say it's blue. You can also add another one at vertical 50. So here it is. I'll make that red, and I'll give it line width. So all these different types of plots, LWD, LTY. You can still use with these functions. And then I'm going to give it intercept and slope. So it's going to intercept with 0. The slope is 1. That's going to be 2. That should be, 0. That's going off a one-to-one relationship. So we can add lines really easily to our plots. The last thing we can probably do is shape. So polygon actually allows us to draw specific polygons. We just need to give it the coordinates of every vertex. So this can be very useful to highlight particular parts of your plot. But again, ggplot is going to do this better than we're going to do with polygons. So I really wouldn't worry too much. Something which is obviously essential is how you save your plots in R. Okay, so no matter what we do, us just looking at it isn't going to be good. We want some other people often to share it with us. When we did R Markdown, that's one way to save plots, because it's just going to save the plot as part of your HTML report. As you notice, plots are actually popping up here in this window. And so every time we do a plot, it pops up in the plotting window inside R. And then I can actually quite easily just export these by either saving it to a clipboard, copying and pasting it into my text or wherever I'm working. Save as an image, and this will give me some options. If you're working inside Illustrator, you often want SVG or BPS. Oh, sorry, BPS. JPEG's good. Maintain the aspect ratio. We can change that. One thing I'll warn you, well, just let me into that. You can also save it as a PDF as well, by size, etc. One thing I'll warn you is when you're making the plots, the size of the window is going to dictate often what it saves like. So here I can, my plot is going to change depending on my window size. So make sure your window size looks sensible before you start saving your plots. So this is how we can interactively save plots. They're going to be there, and we can just save them from this window. And as I showed you, I can set aspect ratios again here if I wanted to correct my windows. What's really useful though is actually we can directly save out in our script our plot straight to a particular device. It's going to be, if we've got hundreds of these plots going, this is what we really want to do. We just need to tell it the type of plot we want to produce. In this case, if I wanted to produce a bitmap, there's a bitmap function, BMP, or there's a JPEG function. I run this, I tell it the file name, I tell it the width parameter of my plot, I tell it the units, here pixels, and I tell it my point size. So what I would do is I would run this, try this. And so do this, we'll give it an actual file name. JPEG. Okay. Now, if I run my box plot, it didn't actually pop up here. Let me clear this again. Put on my box plot. It actually should have got saved straight to file. And I just need to close my window by doing dev.off. And now if I look, I should More go to working directory. Should have test.png. So it saves that now straight to file form. So again, we'll do that again. I'll do something different. So again, I open up an object, open up a device to write to. I'm going to now create test2.jpg. And then anything I went to go plot. So let's do some different plot. Yeah. And then do dev.off. I have to do this dev.off after I've made that plot. That's telling it to close the plotting device. Sounds important. Now I've got test2, and that contains that. If I did that without closing the device, I think it might. It's already open. Do a new one. I think you'll get like an incomplete. It hasn't even created the plot. It's only when I actually flush the device, then my plot appears. That can also be really sad. Like you think you made the plot until you write this dev.off. It's just in your memory. It's just there. Great. If you're ever stuck, I mean, this is a minor thing, but if you're ever stuck and you can't see your plots popping up in your plotting window, okay, so let's try that again. I'm not getting any plots. Right? And that's because I've already opened up a plotting device. And maybe I've forgotten about it. This happens a lot to people. If you're ever stuck and you can't see your plots popping up, just keep running dev.off. Right? And eventually it will tell you error. What that's going to do is just close anything you've currently got. So we're just showing you here, you can save as bitmap, JPEG, PostScript, which is kind of a useful format. PDFs as well. PDFs are really good because they allow you to open up an Illustrator. If you can't afford Illustrator, check out Inkscape. It's a nice open source version. And that's where you can actually take apart elements of your particular. Okay, so that's all we've got to cover for today. I have an exercise on plotting here. If you'd like to run through this, I think this last one's a little tricky. But if you'd like to run through it, please, I will be back here at 2:30. And I will run through all these exercises. I'm just going to stop my share, pause the recording, and then I got a question.